So I know that ABCD is a parallelogram. I want to prove that those diagonals bisect each other. By knowing it's a parallelogram, I know some things. BC is parallel to AD because opposite sides of a parallelogram are parallel. Because of that, I know that angle 1 and angle 2 are alternate interior angles. They're congruent. This is the transversal. The top and bottom are parallel. So 1 and 2 are alternate interior angles. I know that angle 3 and angle 4 are vertical angles. They're congruent. I know that AB and CD are opposite sides of a parallelogram. They're congruent. So there's some triangles, triangle ABE and triangle CDE are congruent by angle, side. And then what I wanted to prove, those segments are congruent by corresponding parts of congruent triangles. Let's go through this again slowly. I know this is a parallelogram, that's given. So I know this line is parallel to this line, because that's the definition of parallelograms. I know angle 1 is congruent to angle 2, because they're alternate interior angles. I know angle 3 is congruent to angle 4, because they're vertical angles. I know AB is congruent to CD because they're opposite sides of a parallelogram, and that's the definition of a parallelogram. So I know that this triangle, ABE, I'm going to color it in here, is congruent to this triangle, CDE, CDE. And since those triangles are congruent, the corresponding parts are congruent. That means this side is congruent to this side, and this side is congruent to this side. Those diagonals bisect each other.